Hi, this is David Martin on the Hybrid Cloud Gateway team. This is a short demo of using the Kuadrant multi-cluster gateway with the multi-cluster services API. So the multi-cluster service API, first of all, this introduces a few concepts. They would be a service export and a service import. The idea being that if you want to use a service in one cluster from a different cluster, you can create a service export to export that service across your network, and then a service import to use it in the other cluster. So then you can address it via service or a cluster set host name, just like you would any other service local to this particular cluster. To demonstrate this with the Kuadrant multi-cluster gateway, I'm going to build up a little bit of an architecture here to show it in action. So we'll have three clusters. We have we'll say a hub cluster up here. That's where our gateway is going to be. And we'll have two workload clusters down here. In each of these we'll have an application running, we'll have a service in front of that. And what we're going to do is create a service export in front of those services on either side, and then import them to the central hub cluster, and that's what we will target with the gateway via HTTP route. So with the gateway API, you can specify, say, a service import as a backend. So you can target a service import just like this. Now, in this case, we're using Istio as the gateway API implementation. So at this time, it doesn't allow, it doesn't support a service import as a backend ref. So there's a little bit of extra stuff we need to do, like create a service with an external name of the cluster set host. But the important thing is you're hitting the gateway here on this hub cluster, and then it's more or less load balancing between the two clusters here with that service. So I've already gone ahead and set up this. So what I'll do is I'll just show it in action, and then I'll go into a little more detail of what that looks like, how it was built up. So I have a few terminals open here. Over here, it's just the multi-cluster gateway controller running. We can ignore that for the most part, but we can see the logs there. Up here, this is logged in with Q control to the hub cluster. Down here and here, we have it logged into the first workload cluster and the second workload cluster. So what I'm going to do down here is just tail the logs of our application, our pod down here in the first cluster, and again the second cluster. And then up here, what I'm going to do is I'm just going to kick off a while loop that's curling our particular host that's going to hit our gateway in the hub cluster. So once we kick that off, we'll see we start getting 200 responses here every second. We can see that initially it's just hitting this cluster on the right, but if we leave that long enough, we'll see that it load balances between the two of them. Now, the multi-cluster services controller will also take care of load balancing, so should one of those apps go offline, it will send all traffic to the remaining services that have been exported that are still actually healthy. So we can see it balancing between the two of them here. So if we cancel out of them, we can see the service export and the service import resources. So let's have a quick look at them. So we are, well, let's look at the namespaces first. Now, everything is in this namespace here. Kuadrant multi-cluster gateways. So if we have a look at pods, we can see our application that we were tailing. If we have a look at services, we can see our echo service in here. Typically, this cluster IP is only accessible within this cluster. But if we look for service imports, we'll see that there's one here as well for that echo service. So to create that service export, you can apply the YAML, or you can use the, in this case, I'm using Submariner as the implementation of the multi-cluster services API. Submariner has a multi-cluster services controller. Excuse me. So Submariner also has a CLI, so subctl, and that will allow you to export a service and create the imports. So you have two options: create the raw resources, or you can use the subctl CLI to create them. And in the walkthrough, we actually do use that CLI. So yeah, we got the service import there. The service export is there too. So I probably should have shown the export first. The reason there's an import here too is that there's when you export the service with the CLI, it actually creates an import back to itself. So even if you address the cluster set host for that service import in the cluster, it will find the right service locally rather than trying to go over the network to a different cluster, unless of course the local instance of that service is not healthy, and then it knows, oh, I should look elsewhere, whatever else is in the, we'll say the cluster set list of IPs. So similar on the second workload cluster, we can see the application pod in here. We can see the echo service, and we see the cluster IP is different. And we can also see the service export, and we can see the service import back to itself. Now, up in the hub cluster, this is where we have our Submariner broker component. So let's pause there for a second and just jump into a little bit about the Submariner architecture to explain how that's set up. So if we go to the Submariner docs, we can have a look at the architecture here. So there's a few important components here. So the broker, I mentioned that. So that facilitates exchange of metadata between the engines, enabling them to discover one another. So the broker in our case is actually deployed to our hub cluster, same one the gateway is on. We have a root agent and we have a gateway engine piece as well. So the root agent, if we look down here, the root agent is this square piece. So every node in a cluster has a root agent, and that takes care of, at the lower networking level, figuring out where does it need to route traffic for the specific subnet that belongs to, say, other clusters. So it will send it off to the gateway node, and that's where our gateway engine is running. So there's a designated gateway node where the gateway engine will run. And that's what actually establishes the tunnel or tunnels between different clusters. So there's tunnels established between the three different clusters here. So there's like a flat network. Initially, you can't say send traffic between the three clusters, but the creation of the service exports and service imports allows us to do that, and also does sets up, say, this service discovery. So it does the DNS stuff for us. What I mean by that is when we create a service import, I should have an example here. So just buried in here, we have an example of what one of those host names might look like. So we have echo.quadrant multi-cluster gateways, that's the namespace, .svc.clusterset.local. So that will resolve to, it will change response each time if there's multiple, say, cluster IPs, but that will resolve to the IP of the actual service on one of the clusters where our service is actually exported from. So in this case, up here in the hub cluster, if we were to dig this particular cluster set host name, we would get the IP address of, say, the service over here, and then next time we do it, we might get the IP address of the service over here. And that's how we saw it, say, hitting either cluster here, and we see the logs alternating between either one. So back to the hub cluster, I wanted to show the service import object as well. So let's have a look at the namespaces first. So we have the same namespace here, and that bit's important. I'll mention a bit more about that in a sec. So, well, first of all, we don't have any service exports. We're not exporting anything from the hub, but we do have the service import here. And if we have a look at the YAML of that, we can see a little bit more information. We have the port that it's using, we have the current status. So there's 2 clusters that it's found that are exporting this service now, or exporting services that are in a healthy state. So that bit's important. Now, how does it actually know, well, where is it? Well, you need to use the host name. What's happening behind the scenes, let me just check this. We should have some endpoint slices. So we have 2 endpoint slices here because there's 2 clusters, and these are the IP addresses that actually get resolved when it looks up that cluster set host name. So that's the bones of the demo and kind of a high-level explanation of what's going on here. I mentioned the namespace there and why that's important. So in the multi-cluster services API, when you export a service and import a service, the namespace sameness is important. So that's why we use the same namespace name down here and up here. Now, there may be permission issues that you need to account for there or manage. So we say if you have a split between, say, whoever administers your gateway versus whoever creates your HTTP route, because your HTTP route is up here as well. Usually that might be closer to where the application is actually running. But you can have other topologies here and still use service exports and imports as well. For example, there is another walkthrough. If I just jump up here, so there's a second one here which takes a different approach, where we have 2 gateways set up for resiliency. So the difference here is it's just 2 clusters. We don't have a diagram here, but I'll try to explain it. Instead of say having a hub cluster, so let's go back to that for a sec. Instead of a hub cluster with 1 gateway, if we imagine that these 2 clusters have their own gateway, and then what's the advantage of exporting a service from either and importing into either? Well, in that case, if the service goes down in one of the clusters, it will automatically reroute from the gateway on one side over across to the other cluster. So it provides that element of resiliency. So that covers everything. You're welcome to try it out, either this walkthrough or the other walkthrough.